Hey guys, how's it going? So today we're going to be looking into this problem called sort array by parity. This is an easy problem. So essentially we are told that we're given an integer array and we need to move all the even integers at the beginning of the array, and this is going to be followed by all the odd integers. So how we can think about it is that we are given this array and we just need to make sure that all the even values have to start and all the odd values have to be at the end. So how we can arrange this is that we can essentially say, okay, 3, we're going to put you at the end. Then we have 1, we're going to put you here. Then we have 2, we're going to put you at the beginning. We have 4, we're going to put you here. So this is one way we can arrange this. This is actually a correct answer. It can be accepted. So they don't necessarily care like if the even values for it come first or it comes second. They don't mind. It can be 4 or 2 as long as the even values are this side and the odd values are this side. So that's what they care about. So the question is, how can we go about this? So the naive way, one way one can think about this problem, it can be like, okay, given this array, we can create two lists, right? We can create a list to hold all the even values, right? And we can create another list to hold all the odd values. So we're gonna start here and say 3, are you even or odd? 3 says I'm odd. We put you here. 1, are you even or odd? 1 says I'm odd. We put it you here. Then we ask 2 and we ask 4. They say that we are even. So we put them here. So when we're done, we just have to like concatenate this list, and when we concatenate them, the even will be here. You see, they are at the start, they will be here. The next thing, the odd will be here. So they're at the end. So this is absolutely a good solution. It's not actually a bad solution. Unfortunately, in an interview, it might not be accepted because of you are using this memory. So we're using the memory of O of n. So maybe the interviewer might say, can we remove using this memory? Can we come up with a solution that is O of 1, right? We're still maintaining the linear time complexity, but the space complexity has to be O of 1. So how can we then come up with that solution? So going back to our to our array, one way we can solve about this problem is that one can say, let's come up with the two-pointer approach, right? So the idea with the 2 pointers is that we're pushing the element, the even element here, and we're gonna push all the odd element this side. So we're gonna start. The first pointer which is left is gonna ask, yeah, are you even or odd? This is gonna say I'm odd. Okay, then we're gonna have to swap you then. Then this side, are you even or odd? Then this is gonna say I'm even. Then we're gonna have to swap you then. Then the swap happens. 4 comes here. What is it? 3 comes here, right? Then we shift these 2 pointers. Pointer come here, the left, and then we shift this another pointer, right, come here. We do the same procedure. The left pointer asks, are you even or odd? Then this says odd. Okay, we're gonna swap you because you're odd. Then this one comes and say, are you even or odd? Then this one says I'm even. Then okay, we're gonna swap you then. We swap them, we bring 2 here and we bring 1 here. So you can see that now we have 4, 2, 1, and 3. We didn't use any memory, so we did this in place. We did the swapping in place. We did not have to like insert these things in an array and like we did here. We did all of these things in place. So the time complexity will be O of n, but the space will be O of 1. So this is not a bad solution at all. So let's go and code it up and see how it works. So this solution shouldn't be hard for us to code. So we have the left and the right pointer. So the left is going to be 0, then the right pointer is going to be the length of nums. Then this is going to be length of nums, but this is going to be minus 1. Then what we need to do is that we need to make sure that the left is less than right, so they haven't crossed over. Then we cannot say, wow, the left is less than right, right? And this is even. So, and this left element is going, it has to be even. So for us to check if an element is even, we do a modular by 2. If this is equals to 0, then it's even. Then we move left by 1. Because if it's even, right, it makes sense. We don't want to shift it to the right. Like, right? It's fine. That's why we're moving left by 1. So it's okay where it is. So we're doing the same thing with the left, with the right pointer. So as long as we're still in bound, and we need to make sure that this is odd. So we're gonna say right element, are you odd? So we're gonna say divisible by 2, but it's not supposed to be 0. So then that means that this is odd. So we're gonna say, okay, you're odd, you're fine where you are. So we're just gonna move the pointer. So you can imagine that if these conditions were not true, if these two conditions were not true, that means that we need to swap this element. So we need to swap them. So it's going to be nums left equals to nums right. So this is how you swap element in Python. So I just need to say nums right. Then here it's going to be nums left. Okay, and I'm just gonna return nums when I'm done. So this should work. Let's give it a try. And it does. I'm just gonna submit, and it works fine. So thank you guys for tuning in. I really appreciate it. I'll see you guys in the next one. Thanks. Bye.